Exercise 7.2. Locate the points of relative extrema of each of the following curves from problems 1 to 10. In the given problems, there are given some functions. We have to locate the points on which we have relative extrema. Relative extrema means we could have the relative maxima and we can also have the relative minima on some specific points, and we have to find down that specific points on which we can find down the relative extrema. And in relative extrema we have 2 points, the relative maxima and the relative minima as well. So for finding those points on which we can find the relative extrema, let's start from question number 1. The given function is f of x equal f of x equals to 2x cube minus 15x square plus 36x plus 10. Now for finding the relative extrema, first of all we need to find down the critical points. For finding the critical points we need its first derivative. So in finding the relative extrema, in finding the points at which we have the relative extrema, first of all we need to find down the critical points. For finding the critical points we need the first derivative. So differentiating it with respect to x, f dash of x, that will be 6x square minus 30x plus 36. Now for critical points, f dash of x will be equals to 0. So let this function equals to 0. This will be 6x square minus 30x plus 36 is equals to 0. Now we need to factorize this function. So it will be 6 times x minus 2 into x minus 3 is equals to 0. You can factorize it through any method using the middle term breaking, or you can also use the quadratic formula as well for finding the values of x. So from here we can get x is equals to 2 and x is equals to 3. So our critical points are 2 and 3. Now we need to use these critical points in the second derivative. So you need second derivative now. So second derivative is 12x minus 30. Now one by one take this critical point, put in it and observe the behavior, whether that double derivative will be greater than 0 or less than 0. If double derivative becomes greater than 0, then we have the relative minima at that point. And if double derivative become less than 0, then at that point of x we have relative maxima. So first of all put the first point, f double dash of 2. In place of x put this 2, we will get here minus 6. That is less than 0. This means f has relative maxima at x is equals to 2. Now in double derivative put the second critical point, we will get here 6, that is greater than 0. So it means f has relative minima at x is equals to 3. So if you look at this method for finding the points at which we have relative extrema, you have to do what? You need the first derivative, find the critical points. How you will find the critical points? Make this first derivative equals to 0. Find the values of x out of it. If you found the values of x out of it, find the second derivative using this first derivative. Put these x values in it one by one and observe the behavior. If the answer is less than 0, then you have the relative maxima. If the answer is greater than 0, then you have the relative minima. If unfortunately it becomes equals to 0, then you will say that no conclusion can be drawn from here, and you will write it like this is the point of inflection. So now move on to the second question. F of x equals 3x4 minus 4x cube plus 5. First of all you need the first derivative, f dash of x, that is equals to 12x cube minus 12x square. Now for critical points make this first derivative equals to 0. So 12x cube minus 12x square is equals to 0. Now factorize it and find the values of x. Out of it, it will be factorized like this. So it means 12x square is equals to 0 or x minus 1 is equals to 0. Out of it, you will get x is equals to 0 and out of it, you will get x is equals to 1. So these are basically the critical points. Now find the second derivative out of this first derivative. So second derivative will be 36x square minus 24x. Now use these points one by one in it. F double dash of 0, this first point in it, this will be 0. So this is basically, we have no relative extrema here. No relative extrema at x is equals to 0. So we will say like point of inflection. This is the point of inflection at x is equals to 0. Now use the second point in the second derivative. So f double dash of 1, f double dash, value of f double dash at x is equals to 1, this is basically 12, that is greater than 0. So it means it has, f has relative minima at x is equals to 1. Now move on to the third question. For third question, we have f of x equals 12x5 minus 45x4 plus 40x cube plus 6. Now first of all, the first derivative, that will be equals to 60x4 minus 180x cube plus 120x square. Now for critical points, f dash of x is equals to 0. So this f dash of x value, make it equals to 0 and then factorize it. I can simply take this thing common from here. So it will be x square minus 3x plus 2 is equals to 0. Now further factorize this term. We will get here x minus 2 times x minus 1. Now either 60x square is equals to 0 or x minus 2 is equals to 0 or x minus 1 is equals to 0. Now from here we'll get x is equals to 0, from here x is equals to 2 and from here x is equals to 1. Now we need the second derivative. So f double dash of x will be equals to 240x cube minus 540x square plus 240x. Now put the values one by one in it. If I put this first value in it, f double dash of 0, this will be equals to 0. So point of inflection at x is equals to 0. Now in the second derivative, put the second point, f double dash of 2, we will get here 240, that will be greater than 0. So we have here the relative minima at x is equals to 2. Now we need to put this third point. So f double dash of 1, that will be equals to minus 60, that is less than 0. So it means we have relative maxima here. Relative maxima at x is equals to 1. So these are the points at which we have the relative extrema. Question number 4 is f of x equals x minus 1 times x minus 2 times x minus 3. For finding the derivative, it will be easier if we just multiply these brackets with each other so that we can easily find out its derivative. After multiplication, first of all multiply these two brackets, we will get here x square minus 3x plus 2 and the last bracket will remain as it is. Now multiply these two brackets, we will get at the end x cube minus 6x square plus 11x minus 6. Now we can easily find out its derivative. First of all, the first derivative will give us 3x square minus 12x plus 11 here. Now for critical points, we need to just make it equals to 0, this first derivative. For critical points, f dash of x is equals to 0. So this implies that 3x square minus 12x plus 11 is equals to 0. Now it will be difficult to factorize it, so we need the quadratic formula here. For the quadratic formula, if we compare it with the quadratic equation ax square plus bx plus c is equals to 0, a here is 3, b here is minus 12 and c here is 11. And the quadratic formula you know very well, that is equals to x equals minus b plus minus under root b square minus 4ac over 2a. Now use these values here inside, we'll get the values of x as x equals 2 plus minus 1 over under root 3. Now we have two critical points. The one is x is equals to 2 plus 1 over under root 3 and the other one is x equals 2 minus 1 over under root 3. Now we need to put this critical points in second derivative. For that purpose, find the second derivative out of this first derivative. So second derivative will give us f double dash of x equals 6x minus 12. Now one by one put these points in it. First of all, this first point, f double dash of 2 plus 1 over under root 3 will give us 6 times 2 plus 1 over under root 3 minus 12. Now we need to simplify it. This is like the different simplification. That's why I'm showing you how I simplified it. This can be done as 6 times. We can write it like this as well. 2 plus under root 3 over 3 minus 12. So it can be 6 plus under root 3 over 3 minus 12. Now this 3 and this can be cancelled out with this 2. We'll get here 12 plus 2 under root 3 minus 12. So at the end we are left with this term. And if you observe, this is greater than 0. You can simplify like this manually, or even you can use your calculator to get this value. You can use the calculator here as well and figure out whether the answer is positive or negative. If it is positive, then this means it is greater than 0. And if it is negative, then this means it is less than 0. So here it is greater than 0. So we have here the relative minima. Minima at x is equals to 2 plus 1 over under root 3. Now we need to put the second point. For that purpose, f double dash of second point, that is 2 minus 1 over under root 3, that will be less than 0 if you solve it. So it means we have relative extrema here. Relative extrema at x is equals to 2 minus 1 over under root 3. So these are the points at which we have the relative extremas. Now move on to the question number 5. Question number 5 is f of x equals sine of x cos 2x. Now this is the trigonometric function. This will be relatively difficult as compared to the previous 4 parts. First of all, find out its derivative. We will use the product rule here. First of all, find the derivative of sine x. That will be cos x. Cos 2x will remain as it is. Plus sine x now will remain as it is. Derivative of cos 2x is minus sine 2x and derivative of 2x is 2. So this term will be simplified as cos of x. Cos 2x will be cos square of x minus sine square of x. I have further simplified it. I have used this identity here. Now this thing will be minus outside 2 sine of x. Now sine 2x has the identity 2 sine of x cos of x. So open the terms, we'll get here cos cube of x minus cos of x sine square of x minus 4 sine square of x cos of x. Now for critical points, this can be further simplified as like cos cube of x minus 5 sine square of x cos of x. For critical points, f dash of x must be equals to 0. This means this term must be equals to 0. So cos cube of x minus 5 sine square of x cos of x will be equals to 0. Now I can take the cos of x common. Inside I will be left with 1 minus 5 sine square of x equals to 0. So it means cos of x is equals to 0 or 1 minus 5 sine square of x is equals to 0. So this thing will be x equals to cos inverse of 0. So it means x could be plus minus pi by 2. Cos will be 0 at plus minus 90 degree. Now out of it we will get here minus 5 sine square of x is equals to minus 1. So sine square of x is equals to 1 over 5. So sine of x will be equals to plus minus 1 over under root 5. So this thing will be equals to x is equals to sine inverse 1 over under root 5. Now we have these terms here. We need the second derivative now. We have first derivative, that is equals to cos cube of x minus 5 sine square of x cos of x. Second derivative. Second derivative will be, we will get here after the simplification, minus sine of x plus 5 sine cube of x minus 10 cos square of x sine of x. This will be the answer for my second derivative test. Use these points in second derivative. F double dash of pi by 2. F double dash of pi by 2 will be equals to 4, that is greater than 0. So here we have relative minima at x is equals to pi by 2. Now f double dash of minus pi by 2 will be minus 4, that is less than 0. So we have here relative maxima at minus pi by 2. Now we need to put the second point, that is we have here plus minus as well. So first of all for plus and then for second. So f double dash of sine inverse 1 over under root 5, that will be less than 0. So we have here relative maxima. You will use the calculator here to solve this, and directly you can just write down that it is less than 0 or greater than 0. Now f double dash of sine inverse minus 1 over under root 5, that will be greater than 0. So here we have relative minima at x is equals to sine inverse minus 1 over under root 5.